All right, let's dive into a topic that is just swimming in hype and confusion: quantum computing and its relationship with crypto. You hear all these huge promises, you hear these massive fears. So today, we're going to cut right through all that noise and get to what's really going on.
It all really boils down to this one single question. It's the big one. It's the question that keeps developers up at night and fuels all these crazy headlines. Is this new kind of supercomputer going to come along one day and just, poof, make it all worthless?
And right away, the conversation pretty much splits into two extreme camps. You've got the alarmists on one side yelling that the sky is falling and the end of crypto is tomorrow. And then on the other side, you have the total dismissers, the ones who say this is all just science fiction that'll never happen. But, as it usually goes, the truth is somewhere in the middle, and honestly, it's way more interesting. So to find that truth, we've got to tune out these two extreme voices for a minute. And it really starts with understanding what people are even talking about when they throw around a term like quantum resistance.
Okay, so let's tackle this head on. What is quantum resistance? It's probably the #1 buzzword in this whole debate. So let's actually break down what it means from a real-world engineering point of view.
At its core, quantum resistance is all about trying to future-proof our technology. It's the idea of creating security methods that could hold up against a very specific type of computer, a massive, stable, perfectly error-corrected quantum machine that, and this is the important part, doesn't actually exist yet. It's still completely theoretical.
The main boogeyman in this whole story is something called Shor's algorithm. And look, in theory, it's a beautiful piece of mathematics. It's designed to crack the very kind of cryptography that protects things like Bitcoin. But again, the key phrase here is in theory. The actual hardware you would need to run this thing on is, well, it's mind-boggling. We're talking about needing over 1 million stable, perfectly working physical qubits. So, what's a qubit? Think of it like a super-powered version of a normal computer bit. A regular bit is either a 0 or a 1. A qubit, because of quantum mechanics, can be a 0, a 1, or both at the same time. That's where all this incredible power comes from. But trying to control 1 million of them at once without any errors, that is genuinely one of the biggest engineering hurdles in modern science. And this chart really puts it all into perspective. Just look at the scale of this thing. That tiny little bar on the left, that's our best-in-class quantum computer today from IBM, with a little over 1,000 qubits. And that skyscraper on the right, that's what we need to even begin to threaten modern crypto. The gap isn't just big, it's a canyon. We are not even in the same ballpark yet. So let's just put this to bed. Based on all the real hardware that exists today and any realistic roadmap for the near future, major cryptocurrencies are absolutely secure from any kind of quantum attack. The fear-mongering about an imminent collapse is just that. It's not based in reality.
Okay, so if we're not worried about a quantum doomsday scenario tomorrow, what should we be thinking about? And this is where the conversation gets a lot more productive and, frankly, a lot more exciting.
Right? Instead of obsessing over this distant theoretical threat, what if we flipped the script? What if we started designing systems that could actually work with quantum technology as it develops? What if we saw this whole thing as a huge opportunity, not just a threat to defend against?
And that leads us to this idea of a quantum-friendly design. See, this isn't about making some wild claim that you're immune to future tech. It's about being smart. It's about building a system today that is flexible enough to integrate new security standards down the road and can even use early-stage quantum computers for useful work as they come online. And here's the key difference in philosophy. Quantum-resistant is all about playing defense. It's about preparing for a hypothetical battle way in the future. Quantum-friendly is about playing offense. It's a real near-term engineering opportunity that we can actually start building for right now. So, let's make this concrete. Let's look at a real-world example of this friendly philosophy in action. There's a project called Qubitcoin that's taking exactly this pragmatic approach, rather than just shouting about resistance. Their entire approach is based on these 4 pillars, and it's just a really clever way to tackle the problem. First off, start with what works. Use the same battle-tested classic security that protects Bitcoin. But then, and this is the cool part, build a system that's ready to evolve. They designed the mining process to be future-proof and made the whole network upgradable for whatever new cryptography comes next. Now, the most interesting bit is definitely the mining. You see, with traditional crypto mining, it's basically an arms race. Whoever can afford the biggest, most powerful brute force hardware wins. Qubitcoin's mining, on the other hand, rewards something different: cleverness,
It rewards algorithmic breakthroughs. Success isn't about raw power, it's about how efficiently you solve a problem, which just so happens to be exactly what the field of quantum computing is all about.
And because of that design, the blockchain itself becomes this incredible real-world laboratory. As scientists develop new hybrid algorithms that mix classical and quantum computing, they can actually use the Qubitcoin network to test their ideas. It creates this amazing feedback loop that can actually push the whole field forward.
So what's the big takeaway here? Why does this practical, engineering-first approach actually matter so much in a space that is so often filled with just noise and marketing?
Because it works on every level. It's secure today, using the cryptography we already know and trust. It's scientifically useful today with a mining process that benefits current research. And it's ready for tomorrow, because it's built from the ground up to be flexible and to adopt new standards when the time is right.
Ultimately, this kind of thinking gives us a path forward that isn't one of the two extremes. It doesn't fall for the hype, but it doesn't just dismiss the future either. It's a responsible middle ground. It's about actually building something useful, not just bragging about what you can theoretically survive or burying your head in the sand.
And this line just perfectly sums it all up. The goal here isn't to just slap a quantum sticker on a coin for marketing buzz. The real goal is to build something that is robust, that is responsible, and that is truly ready for the quantum era, whenever and however it finally arrives. And that, right there, is a very small but a very powerful difference.